So without much further ado, I just want to quickly get started. Any of you here may or may not have heard of Frontdoor. What it is you may have heard of American Home Shield or HSA. Its brand has been around for almost 50 years, category leader, all that stuff. I'm sure you guys are not really interested to hear too much about that, other than to say, I just want to put it out there. That's what we do. We are over, 2 million or so members. We got a lot of contracts going all over the place. And we have a network of independent contractors, like around 17K or so independent contractors that we have. So we got a lot going on. And we're almost like, close to $2 billion organization that's been around for a while. So quickly, kind of get through the agenda very quickly. I just want to give you a sense of who it is, what we do. I think we kind of went through what the business is, but I just want to give you an organizational structure of where we are, what we did with it. So we are a centralized, one of those kind of things where it's centrally governed, but yet it is a distributed governance model, if you will. So I'm the head of the data engineering myself, and I've been in this field for, I don't know, a few decades in various forms over the years. And then Niklesh here, who's on my team, who is our ML engineer, who's we'll be talking through some of the nitty-gritty of how we went about implementing and using notebooks at scale. So what does that mean at scale? We all know the typical role of a data scientist or a data analyst or any of those kind of folks as we go through with it. We're kind of going to walk through very quickly some of the personas of what those different independent people do, right? We all know what they do, but how do they do that within the world of Snowflake? How can we use the concept of the data gravity, which is what Snowflake is about, right? Data gravity, bring all the data in, it's already there. Why don't you bring in computation, development, everything right in the same place as we go through with that? So that's the kind of the core thesis or the genesis of where we want to go with that. And so what I want to quickly kind of go through with this here is kind of, just going to give you a sense of what is a home warranty. It's a year-long renewal plan that covers home system and appliances and so on and so forth. So going on to the next one. Very quickly, we want to talk about what do we mean by data solutions here. Some of the business challenges that we go through with it, I just want to quickly go through that, kind of set the context. Coverage prediction. Again, as I said, we're a home warranty, we've been around for a long time, and then we do like millions of contracts that are there. We want to be able to predict which of these appliances are we able to fix, and so on and so forth. Like for example, if you have a refrigerator or any of the appliances that you have at home, it could be an AC, it could be an HVAC system, and so on and so forth. We should be in a position to be able to use some of the modeling techniques to be able to understand how those things kind of work through with it. And is it something that's going to be able to covered? Do we get some prediction model that go through with that? In addition to that, we also want to go through the concept of real-time home warranty insights, meaning all those contracts, they all have different appliances, different homes have different history of it, so on and so forth. So we want to kind of pull all the pieces of that together, build some feature engineering into it, and do some real-time home warranty kind of thing. And then we use Cortex Analyst or a variation of that to kind of be able to parse through that as you call your customer service reps to be like, hey, is this something that's covered? Is it something that you can be able to do that? So those are some of the things that we go through with that. And of course, there are some interesting development challenges that we go through with it. So Niklesh, do you want to kind of quickly talk about some of that?
Hey, everyone. This is Niklesh Urela. So I would like to, first of all, thank you, Kishore, for giving the introduction about the various business applications. So I would like to go over a few of the common development challenges that we have encountered during the development of these phases. Particularly, the first biggest challenge that I would like to cover is the reduced efficiency. This happens particularly when the teams relying very heavily on local development environments to handle large, complex, and resource-intensive data workloads. It's not just the limited compute power that slows down the progress, but it is also the additional overhead of pulling the data from the cloud. And also, this introduces the inconsistencies between the local setups across team members and the difficulty in maintaining the reproducibility. These factors collectively contribute towards reducing the efficiency, and it affects the collaboration and increases risk in both analysis and deployment stages. The other common challenge that we often encountered was the data security. Every time the data is exported from the secure platforms to local machines or external systems, it introduces potential risks. Further adding to the risk, it makes it very harder to track, audit, or manage operations on the data. The other common challenge is the data consistency. It is also a very critical piece not just for accuracy but also for the trust. When various teams relying on local development environments and work in isolation, the consistency breaks down very quickly. With that, I would like to go a little perspective of how it would look like for a data analyst. Let's take a typical workflow of a data analyst. And for example, the business will reach the data analyst with a business question, and the data analyst will write a SQL query and probably test it and do some visualizations and tries to deliver the results back to business. While the workflow stream pretty straightforward, relying on local development environments, introduces several challenges. It becomes difficult to standardize these practices, track all the changes, and collaborate very efficiently, both across the teams and within the same team. Beyond the common issues like data security and data consistency, this approach often leads to like redundant work, and without a proper version control like GitLab or GitHub in place, there is little to no cross-validation of scripts, which increases the likelihood of errors and reduces the overall accuracy. Over time, this also makes it more harder to reproduce results, ultimately leading to longer development cycles. With that, I would like to show a little perspective of data scientist as well. For a typical data scientist, while understanding the business problem and identifying the right data sources, they start by exploring and cleaning the data and performing various stages like model training, model validation, and tuning the models, often iteratively. While the data scientist's workflow involves collaboration with other teams like data analysts, the nature of their work requires handling large volumes of data, depending on external data sources like weather information, weather inflation data, etc. With playing with such a large data sets at every stage of the data science pipeline, from exploratory analysis to feature engineering and model training, it can be like severely impacted, and particularly when, although any version control system like GitLab or GitHub is in place, working locally creates a lot of resistance among the data scientists to share their work or collaborate efficiently, leading to further delays and redundant efforts across manual efforts during the deployment automations. A very quick perspective of a machine learning engineer. A typical workflow of a machine learning engineer looks like the problem definition and collecting the data, ensuring that the right data is gathered and aligned for the business goals. And once the data is gathered, it will be pre-processed, clean, and it will be went through a lot of machine learning development stages like model training, model validation, model registry, and also making all these models available for the production where it is integrated into business applications via REST APIs or any other systems. Finally, the major goal of ML engineers is to monitor and maintain the model's performance in the production environment. While that's how the workflow looks like for the machine learning engineers, but when they have the flexibility to use different tools and different frameworks, it will introduce significant challenges in terms of cost, particularly when they use a lot of other external platforms like AWS and Google Cloud for various tasks such as feature store management, or like model registry, model serving, and model monitoring. All these contribute towards various compute costs, and it will quickly increases the infrastructure complexity and as well as integration complexity, and also contribute towards a lot of compute costs, further playing more amount of dollars. With that, I would like to give it to Kishore back.
Yeah, and I think as we just Nicolesh laid out, right? We all walked through all the different lenses. Now, how do we address those things within the concept of a enterprise data platform? Again, this is our point of view. This is our experience of having used Snowflake, all the different features within that. So one of the approaches that we took very early on is always been with version control. And again, typical data scientists and data analysts, it's not necessarily a common thing. For a lot of us who have been in the engineering side of it, been development side of it, we've been doing it for decades. Nothing unusual there. But for data scientists and for data analysts, for any of those folks, it's not something, at least that we have seen within our organizational side of it, and I worked in many organizations. And they generally try to do things on their own. They like to use their own laptop. They want to use their own thing. They want to have the data in a pretty much ungoverned way. So we really want to kind of bring all that together in one place. And that's kind of where, for example, Niklesh working very closely with our finance data science team, embedded it and kind of really created that version control mechanism around it. And to do that, we obviously use GitLab, and so we integrated that within that kind of to bring about the data consistency and so on and so forth. And the coreness of all of that, as I was saying earlier, is about the data gravity. Data is already there. Bring it all in. Don't move data around. Don't monkey with the data. Just don't move it around. Just leave it the way it is. Leverage it. Use it for what it's worth. That's the right thing to do. And I think we have found it to be really useful. And also, it's made our CISO really happy. It made our governance people really happy. So everybody kind of feels a little bit more comfortable about that notion of doing that. And moving on to the next one.
Yeah, with that, I would like to go over a few of the phases of transition that we used and transferred our data analysts and data scientists into the Snowflake environment. So the first phase of transition we employed is to enforce a version controlling mechanism, particularly the GitLab. And with GitLab integration into Snowflake, we enforced various teams to update their repositories very regularly. And this indirectly helped us in setting a common platform for all the teams to work from single source of data. And the second phase of transition that we used is the Snowflake Notebooks. With Snowflake Notebooks integrated completely with the GitLab, it gave us like a very collaborative and version control development environment for various teams. And it gave the flexibility for all the teams to perform various tasks like perform exploratory analysis or develop a lot of machine learning models, and as well as a lot of doing machine learning activity, all without moving data out of the platform. So this setup streamlined our workflows for data analysts, data scientists, and machine learning engineers by maintaining a single secured environment for both development and deployment. So just to give a broader perspective of how the transformation looked like and the advantages it brought in. So one of the key improvements was eliminating the need for transferring data in and out of Snowflake. And by creating dedicated warehouses for various teams, for data analysts and data scientists, we ensured that all the compute-intensive tasks could be performed very smoothly and very directly within the Snowflake environment using the Snowflake Notebooks. So yeah, one other point is like this not only enhanced performance and security, but also streamlined our workflows by keeping data processing and analysis and a lot of analysis centralized. And if you could see in the picture, like all the data scientists and data analysts are being brought into a common platform, which is the Snowflake Notebooks, and everyone working there for their various workloads. As phase 3 of our transition, we tried to leverage Snowflake ML capabilities, and we were able to build end-to-end machine learning capabilities entirely within the Snowflake ecosystem, using the Snowflake tools like Snowpark, Python UDFs, and we could perform all the tasks like data preparation, feature engineering, model training, and even model inference, all without moving the data outside the platform. This approach ensured data security and improved our performance, and as well as simplified our governance a lot. And by integrating all ML workflows directly into the Snowflake, we reduced reliance on external platforms like AWS and the Google Cloud, and accelerated our path from experimentation to production. So just a quick overview of how the transition has looked like for our feature engineering step. So using the Snowflake ML's key ability to support feature engineering and feature store capabilities directly within the platform, our ML engineers could leverage the flexibility of transforming raw data into high-quality features. And once these high-quality features are built during the development phase, they were made available across the teams, not just for machine learning engineers, but also for the data scientists as well. And so that this ensured our ensuring consistency and reduced duplication of effort. And this tight integration streamlined the path from data to model deployment while maintaining a secure and unified development environment. And this transition also reduced our cost in using these external frameworks. And one other Yeah, one other key feature that we used was the Snowflake ability of model registry and model serving. With all the ML, engineers could enable a seamless workflow from development to deployment. The model registry allowed our teams to track and manage multiple versions of ML models within one location, making it easier to monitor models' performance and deploy best performing models to production. And currently, we are in the process of transitioning our existing models, which are in the external platform, towards the Snowflake ecosystem. And this part of effort is also made sure that we move from external systems to Snowflake very gradually, so that none of our customers get affected. And this ongoing transition, as mentioned, it helped reduce our cost in building and maintaining all the ML engineering stages like feature engineering, feature store, model registry, and various other pipelines. And the main one more additional advantage that we could use was run all these pipelines in an automated fashion using Airflow triggers. So this way, like everything is automated from various stages, like the model training to the deployment, and everything happens within automatically. And once all these workloads automatically either using notebooks or containers, depending on the various needs of the required pipeline. And with that, I'd like to go give it to Kishore back.
Yeah, just one quick thing on that. I think one of the core principles we kind of adhere to is try to use managed wherever you can. Reduce the number of bespoke coding if it's appropriate. Again, managed Airflow, managed aspects to every one of those things that we do. It's not value-added work trying to build your own custom thing. You leverage whatever is already there. It's a combinatorial thing. Gone are the days when you kind of have to build things on your own, especially not in the world that we operate and the things that we do. So don't even try to do that. It just doesn't have much value. So moving on to current and future cases, right? There are a couple of specific use cases that we kind of honed in on, especially as we're kind of going through our transformation within our world, both within the finance and the other parts of the organization. One of the things is we are trying to get through our business processes and identifying areas of focus. Like, what are some manual processes that we currently run today? And you might wonder, who in these days gets physical checks, right? We all do, especially if you're working with certain sectors or certain areas of the business, if you will. Like if you're if you're having somebody come in and do plumbing work in your home, right? You typically write them a check, or sometimes a variation thereof. So what happens is we get a lot of those physical checks because we go through our vendors, we go through our contractors who then kind of send us back. And so there's a lot of manual check processing that needs to happen. And what better way to do that than use DocAI? So anyway, that's just one use case of that. Going to go through with that. And then one last thing is every company probably has this duplicate data or duplicate identifier, right? You need entity resolution, which is a very common thing. So one of the things we're trying to do with that is, especially with our number of agents that we have, real estate agents and so on and so forth, we get data from multiple data sources in addition to our own. So we want to entity resolve that. We want to de-identify some of those things. So to make that effective, we are trying to go through a couple of options. One of them is we're using sensing. We look to some other ones, but also we're looking at graph analytics from Neo4j. We're starting to work with them as well. So there's some combinatorial things of those two that we're trying to figure out how we can get this entity resolution come to bear.
So I would like to show a quick demo of how we use notebooks for all the various stages. A quick rundown here. So all the various stages that usually happen, like all the data is read from the tables, from within the Snowflake tables, and all the feature pipelines are built and stored back into the required database tables. And once all the model training is done, we just log our models using the model registry, and using various stored procedures created to automatically launch these various stages of ML development. Those are all stored as in like a stored procedures, and you guys can see like all the models appearing here. And as well as just want to show a quick glimpse of the feature store usage as well, and just clicking into entities, like all the various custom features that we build using our company's data, they all are transformed and as well as stored into the feature store, so that it is made available for all the users within the Frontdoor organization.
Yeah, thank you, everyone. Thank you for your time. Appreciate it.